Alright folks, so we are diving back on into our talk about integration by parts. And so in our last video we defined what integrating by parts was, but probably more importantly we looked at the approach into how to choose a U and your DVs for our integration by parts. And we kind of focused on the LIPIT acronym. You first try to make a U a natural log if that's not in the cards. You'll try to make an inverse trig function a U. If that's not in the cards, you'll try to take a polynomial. And if that's not in the cards, you'll try to take an exponential. And then finally, you'll try to look for a trig function. Alright? And so that is a good focus point. And again, I'm not going to say this is 100%, all the time. But this is a really, 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 really good focus of where to choose your U's from, okay? And especially in our curriculum that we're going to be looking into. So we got an example here in which our goal of this video is to look into what happens if we have to have a repeated use of integration by parts. So it'll happen twice in the same integration. So let's take a look here real quick. Let's first and foremost find out what our U and our dv are going to be for this case. So we want to first and foremost look at the possibilities. Well, no natural logs, no inverse trig functions. LIPIT next would be the p, our polynomial. So it looks like x squared will probably be our best bet to be our u in this case. So let's go ahead and we'll say that u is going to be x squared, thus dv is going to be e to the x times dx. So there's our u and our dv. So let's go ahead and find du. So this leads us to show that du is going to be 2x dx. And then we also want to integrate dv. And so by integrating dv, or e to the x, we know that the integral of e to the x, v, is just going to be e to the x. So far we've analyzed our 4 parts that we need for integration by parts. We need u, dv, du, and finally the regular function of v. So let's quick little reminder, our integration by parts formula is the integral of u times dv is equal to the multiplication of u times v minus the integral of v du. Alright? And so now let's kind of go back and look at our information that we have. We've gone ahead and identified those 4 parts. And let's go ahead and substitute them on in and see what we have. So pushing down on forward, we're going to see that x squared ex dx, that will end up equaling, alright, this right here ends up equaling x squared, there's our u, times our v. We just said that our v was e to the x minus the integral of x times e to the x. And I'm going to go ahead and put this 2 on the outside just to keep things a little bit nicer and cleaner in this case. Maybe you'll see why here in just a sec. And so now let's take a look. So now we've got a little bit of an ease factor happening on in here because the new integral that we have, our x times e to the x, this is a little bit of an easier integral to go ahead and integrate versus when it's x squared. It's not crazy different. It is a little bit different, but it's not much more difficult to kind of go ahead. And so that x times e to the x, that's just another integration by parts. And so we have to do it twice, and that's where our repeated use comes from in this example. And so we're going to use integration by parts again in this scenario. So I'm going to change colors. And so for the new integration by parts, we're going to go ahead and once again our polynomial is there. So we'll make u equal to x. We'll make the dv equal to e to the x times dx. du will end up just being 1 times dx. And then v will once again just be e to the x. Okay, there's our 4 parts for the new integration in here. So I'm going to go ahead and bring down in blue what we originally, I guess, kind of had and we're focused on as we're dealing with these. And so we have x squared e to the x, and then we'll be minusing the integral of what I have in green, all right, or underlined in green here. And so this in green, the u would be x, the v would be e to the x. So all I'm doing right here, guys, is I am taking this part and I am integrating this by parts. And so my u, x, my v, e to the x. And so that's kind of what I'm doing in here. And now continuing to push forward, that would be subtracting the integral of e to the x. Okay, and so now we're subtracting the integral of e to the x dx. Alright, so there is our v times du. v times du. Hopefully you're still with me. Okay, now we're getting somewhere. I'm going to bracket this off just to kind of simplify it for a little bit for us. And I'm going to continue to move down in different colors. Now let's simplify what's hanging in green. And so you still have x times e to the x minus the integral of e to the x. Well, the integral of the antiderivative of e to the x is just going to be e to the x, right? And so this is e to the x happening in here. All right, we're pushing forward and we're moving along, okay? And so as we continue to get down to that very bottom, what I don't want us to forget is the 2 that came along for the ride the entire time. So I'm going to put that 2 back on the outside. We don't want to forget that 2, all right? We didn't really focus on it as we were moving on, but we want to bring that 2 that came along for the entire ride for this whole process. And now, as we finish up our simplified answer, I'll put it in red, we have x squared times e to the x minus, I'm going to distribute that 2x e to the x minus, or excuse me, plus now because it'll be positive, 2e to the x plus c. Alright, so a lot going on in there, but really nothing is different. We just had to end up doing integration by parts twice in this scenario. Alright, so I want you to go ahead and give one other one a shot on your own, which may end up having to do a second integration by parts. So let's go ahead and take a look here. Your example is going to be, please integrate x squared times e to the negative x this time, and then dx. And then your answer should end up being negative x squared times e to the negative x minus 2x e to the negative x minus 2 times e to the negative x plus c. It's going to be a very similar approach, but obviously it does change a little bit when we have that negative x hanging on in there. So give this one a shot on your own, see if you come on up with our answer, and that's going to do it, folks. On to the next one.